Well, hello, this is Miss Billerbeck, and I'm starting section 9.2. So 9.2, we're going to start with a general term and a rule for the term. So if we want to find the second and the ninth terms, that is term, then we just change the subscript and put 2 n for n. So we have t to the second, or t, the second term, it's not t squared, it's the second term equals 2 times 2 plus 3. So if you notice, I just substituted 2 in where the n is. So this is 2 times, and 2 plus 3 is 5. So t, the second term, then is 10. If we want to find the ninth term, we put in 9 for the n. So we have 9, and then 9 plus 3 equals 9 times 12, and that ends up being 108. So that's what they're asking you to do when they ask you to find the second. Ooh, I misspelled second there. Okay, the second and the ninth terms. So let's look at the next example. So in this example, we're given 4, 5, 7, and 3. So this time we want to find the general term, but we've got this. We know how to do this. So we're going to set this up, and we have n and tn. Okay, we remember we want to have, if it looks like it might be changing a certain way, we want to make sure we have a 0 term. But our first term is 4, and our second term is 7. Our third term is 10, and our fourth term is 13. And let's see, they want us to find the 15th term, and also a rule for t to the n. So if we look at this, this is a plus 3, this is a plus 3, this is looking good, and this is a plus 3. Hey, we've got a constant change, so that means we've got a linear expression. So we can tell we can't go all the way to 15 just yet. So let's back up that step. But we know that we added 3 to get 4. So 4 minus 3 is 1. So we have some important information now. So we have Tn, and we have n plus how it started. So it changed by positive 3. So we put a 3 there, and then it started at 1. So we end up, our general equation is 3n plus 1. So now if we want to find the 15th term, we put a subscript 15, and we have 3 times 15 plus 1 equals, and 3 times 15 is 45, plus 1 equals 46. So now we can write 46 confidently in our little chart. Okay, so let's look at example 2. Oh, okay, so we don't have numbers, we have just a pattern. All right, in life, we don't have always numbers, but we have to examine and see patterns, and it helps us predict the future. So we have 1 dot here, and then that same dot is here, but then we're adding 1, 2, 3, 4 dots to that. And then this one, we're adding 4 dots to that. So we just keep adding 4 more dots. So figure 1, we have 1. Figure 2, we have 5. Figure 3, we have 5 plus 4 is 9. So we know that we're adding 4 each time in this pattern. So if we want to figure out figure 4, we just add 4 to 9, which is 13. And then we can come back, and we know we added 4 to get to this 1, so that 1 minus 4 would be -3. So -3 plus 4 is 1, and so that we did get the right figure 0. So if we look at Tn, we look at how did it start? I'm sorry, how is it changing plus how it started. So it's changing by 4, and it started at -3. So when we simplify this, we have 4n minus 3. So to predict what T18 would be, the 18th term, we'd have 4 times 18 minus 3 equals, and 4 times 8 is 32, carry the 3, 4 times 1 is 4, plus 3 is 72, minus 3 gives us 69. All right, so the 18th term. So we can write that right here. So let's look at another interesting example. There we go. If any of you recognize this, this is chemistry. This is a carbon atom. Okay, so or actually yeah, I'm not big on chemistry, sorry. I wish I was better at it. So this kind of gives me as much anxiety as math gives some of you, so it helps me relate. So we have chemistry, or C for carbon, and then we have these hydrogens out here. So there's 4 hydrogen molecules for a carbon, per carbon. Then we go to our next molecule. We have 2 carbon molecules, and then it combines with 6 hydrogen. And then here we have 3 carbon molecules, and we have 8 hydrogens. So if we want to have a rule for how many hydrogens can attach to a carbon, we can start looking at this as, okay, there's 1 carbon to 4 hydrogen. When you have 2 carbons, you have 6 hydrogen. When you have 3 carbons, you have 8 hydrogen. So we can imagine that when we have 4, we have 10 hydrogen, and this would be 2. The library at this time. Thank you. And 2, and 2. Oh, I might have just got saved from teaching a little chemistry. So then this is plus 2. All right, so if we look at how we can predict this, our carbon molecule would be Cn, and our hydrogen molecule will be how it's changing. So that's 2 times n plus how it started, 2. So we would write 2n plus 2 down here. So then we can predict if we had carbon 10, then our hydrogen would be 2 times 10 plus 2 would be 22. All right. Well, I got to go to a meeting, so I'll talk to you later. Bye.